Hello, Oak Hill. Welcome to day 3 of at-home learning. It's a great day to be a mathematician. Today we get to add and subtract those rational expressions with unlike denominators. We've been building up to this the last few days, um, so it shouldn't be too difficult because we've got our basic skills learned, and we're just building one small step on that. So, like I've said, we've already practiced the skills to add rational expressions with unlike denominators. We're going to put all those skills together, and here is a list of things that you do to add and subtract these fractions. So first you're going to find what the least common denominator is. You'll make the two new fractions with that least common denominator. You'll add the numerators or subtract the numerators, and then you'll simplify that fraction if it reduces. So let's look at some of these examples. First one's very easy. I have a denominator of 4 and 8, so clearly the common denominator between 4 and 8 is 8. So what I like to do is I make two new fractions, each with that common denominator of 8. And then I just ask myself, from previous denominator to new denominator, what did we multiply by? So from 4 to 8, we multiplied by 2. So whatever we did to the denominator, we have to do to the numerator. So the numerator gets multiplied by 2 as well. A times 2 is 2a. The second one, from 8 to 8, the denominator didn't change, so the numerator should not change either. And then I have 2a over 8 minus 2a over 8. So remember, you do what the numerators say. 2a minus 2a is 0. 0 over 8 just really reduces to 0. So number 2 is a little bit tougher. So we're going to practice those skills like we did yesterday. Let's start with the coefficients. Between 10 and 25, remember it's best to start with the bigger one. 25 times 2 is 50. Does 10 go into 50? Yes. So I know it's going to be 50 for my denominator. And then I look at my variables. And remember, you take the highest exponent. So x squared is bigger than x to the first. So it's going to be 50x squared for my common denominators. And I've got my plus sign in between. Then I just have to figure out from previous denominator to new denominator, what did we multiply by? So from 10x squared to 50x squared, we just multiplied by 5. So that means my top will get multiplied by 5. 3 times 5 is 15. And then same question, from this denominator to that, the new one, what did we multiply by? So from 25 to 50, we multiplied by 2. From x to x squared, we multiplied by x. So we take that 7 and we multiply it by the 2x, and we get 14x. Now that we have common denominators, we're able to do what our numerators say. It says 15 plus 14x. Those aren't really like terms, so they'll just get stuck next to each other. And in the correct order, 14x would be first, 15 would be second, and it goes over that common denominator of 50x squared. Remember, the denominator does not change. You just do what the numerators say. Then you just have to look, does that factor? Is there a GCF or anything like that? And I don't see anything, so that is as far as that will go. So now would be a great time to pause the video, try 3 and 4. They're just like 1 and 2. And then unpause it when you're done and we can compare. I'll explain it here in just a second. Okay, number 3. You should have found a common denominator to be 15. From 5 to 15, you multiplied by 3. If you multiply your numerator by 3, you get 6x. This denominator did not change, so the numerator should not change. And much like number 1, if you subtract something from itself, you get 0. 4 is more interesting. So let's see, the common denominator. I like to again start with my bigger number. 12 times 2 is 24. Does 8 go into 24? Yes. So I know my coefficient is going to be 24 for my common denominator. And then for the variables, you take the bigger one. A squared is biggest. So it's going to be 24a squared for my common denominator. Then I just have to figure out, what did I multiply by? So from 8 to 24, we multiplied by 3. From a to a squared, we multiplied by a. So I take my numerator and multiply it. 7 times 3a is 21a. And then next one, from 12a squared to 24a squared, from 12 to 24, we multiplied by 2. A squared and a squared, that one did not change, so I'm just multiplying by 2. 5 times 2 is 10. Put those numerators together, 21a plus 10 are not like terms, so they stay separate. They are already in the correct order over that common denominator of 24a squared. Again, there's no GCF, so that fraction is not going to reduce. All right, we'll move on. Number 5 is slightly more. Look at that first denominator. Remember, it's best to factor denominators if they factor. So we're going to factor that. Hopefully you recognize that to be a difference of squares. So it factors very easily to the square root of the first term, which is x, the square root of the second term, which is 2, 1 plus, and 1 minus. So it factors to x plus 2, x minus 2. Once you have that, we can find the common denominator pretty easily. So they already have the x plus 2 in common. They also need the x minus 2. Remember, whenever you're dealing with binomials and things like this, you just kind of mush them all together. But if there's anything in both of them, you don't repeat them. So x plus 2 and x minus 2 is going to be my common denominator. So I'll make 2 fractions, each with that common denominator. I'll put my minus sign in between. And then you just ask yourself the same question. From previous denominator to new denominator, what's new? Well, this denominator did not change, so your numerator should not change. The second denominator, however, did change. What's new from x plus 2 to x plus 2 times x minus 2? Well, obviously, the x minus 2 is new. So my numerator will have to be multiplied by the x minus 2 that is new. And then you're actually going to want to distribute that, and I'm going to distribute it as I rewrite it as my numerator. So 3 times x is going to be 3x, and 3 times 2 is going to be 6. And then you just have to remember whenever there's a minus sign in between whenever you're subtracting and you have a binomial for a numerator, you have to distribute that negative. So I'm going to do that before I combine my numerator. So this is going to make that a negative 3x, and this is going to make that a positive 6, and then I'll just kind of ignore that sign now. And then if we combine like terms, I have 6x minus 3x. That gives me 3x, and then the plus 6 kind of tags along. All right, and then we put that over the common denominator of x plus 2 and x minus 2. And then you always have to check, does your numerator factor? Is there a GCF? And on this one, yes, there is. There's a 3 in common. So we want to think of this as, if there's a 3 in common, it would be 3 times what would be left, x plus 2. So let me rewrite that down here. 3 times x plus 2 over x plus 2 times x minus 2. So if you look at that, we can cancel the x plus 2's that are in common in the numerator and denominator. So those cancel each other out, and that's going to give us our final answer of 3 over x minus 2. And again, you don't need the parentheses anymore on the bottom, but you can certainly put them if you want. So you see that one, a lot of steps, but it's really not too difficult of things. You just got to pay attention and make sure you don't make any of those silly mistakes. Number 6, let's look at that. What would the common denominator between 3t and t plus 1 be? So again, remember, because of the addition, that t is not in common. So the common denominator is just those things mushed together. 3t times t plus 1. So I'm going to make 2 fractions, each with that common denominator. So from 3t to 3t times t plus 1, clearly the t plus 1 is new. So the top needs to be multiplied by t plus 1. If you distribute that 2, it would be 2t plus 2. Second fraction, obviously the 3t is new. So the numerator needs to be multiplied by 3t. 5 times 3t gives me 15t. Okay, and now that we have common denominators, we just put our numerators together. 2t plus 15t would give me 17t. I've got the plus 2 that tags along over the 3t times t plus 1 for my denominator. I look at my numerator and it does not factor, so that's as far as this one is going to go. We cannot cancel these t's out, remember, because this one's being added. So nothing's going to cancel there. And that's all you can do on number 6. A little easier than number 5 that time. Number 7, okay, I'm looking at this denominator. The first thing I notice is that denominator is not in the correct order. So what I would do is put it in the correct order. That would be negative x plus 3 in the correct order. And then remember, you don't really want your first term to be negative, so we're going to factor out the negative, which is going to give me x minus 3. Okay, now, this negative in the denominator is awkward to have, so we really want to float it up there to the front. So I have a negative and a negative, which is really going to make a positive. So this all becomes 7 over x minus 3, really, plus 9 over x minus 3. So you see that we've made it to where they do have common denominators already, just by rearranging that order. So this is a nice and easy problem once we rearrange it. We just have 7 plus 9 is 16 over x minus 3. Again, nothing's going to reduce there. Flip it over to the back. We have a couple more examples. Number 8 is not too difficult. So remember, if you have a whole number, you can put it over 1. So what would the common denominator be? Well, between 1 and b plus 3, clearly it's going to be b plus 3. So we make 2 new fractions, each with that common denominator of b plus 3. From 1 to b plus 3, we're obviously multiplying the whole thing by b plus 3, so we need to distribute that 2 through. 2 times b is 2b. 2 times 3 is 6. And then from b plus 3 to b plus 3, that denominator did not change, so the numerator should not change either. I'm adding, so I just look for those like terms. 2b plus 1b gives me 3b, and then the 6 will tag along over b plus 3. And then I'm looking at that numerator, does it factor? And you should say yes, there's a 3 in common. So if we were to divide that numerator by 3, that would leave us with b plus 2 over b plus 3. It doesn't cancel anything out, so that would be our final answer there. Remember, you can't cancel those 3's out either because of the addition. It's got to be multiplication to be able to cancel things out. So that's as far as it goes. It did factor, but it didn't really help us cancel anything out, and that happens sometimes, and that's okay. Number 9. Okay, looking at some things that'll factor this time. So I see that this is a trinomial that's going to factor very easily. I can go ahead and I know it's going to go to the 2 parentheses right off the bat because there's no term in front of that there's no number in front of the first term, so it's going to be x and x. My third sign is positive, so I adopt the sign of my second for both, so it's going to be x plus and x plus. And then the only factors of 1 that add to 2 are 1 and 1, so it's going to be x plus 1 and x plus 1. This one's a difference of squares. It factors very easily as well to x plus 1 and x minus 1. The square root of each term, 1 plus, 1 minus. Okay, so we've got those denominators factored. Now we can find the common denominator. So this one has 2x plus 1's. This one has 1x plus 1. So the common denominator is going to be the most, which is 2x plus 1's, and then the additional x minus 1. So it's going to be x plus 1 times x plus 1 times x minus 1. So we'll make 2 new fractions, each with those common denominators of x plus 1, and x minus 1, and the plus sign in between. Okay, so we look at our previous denominator, look at our new denominator. What is new? This one, the x minus 1 is new, so the top needs to be multiplied by x minus 1. If we distribute that 2x through that parenthesis, we would be left with 2x squared minus 2x. If we look at our second fraction, it was x plus 1 times x minus 1. The new thing is an additional x plus 1, so we multiply the top of that fraction also by x plus 1. Distribute that x through, and you would have x squared plus x. Okay. And then we want to combine those numerators. So it says 2x squared plus 1x squared, which is going to be 3x squared, We've got a negative 2x plus a 1x. That's going to be a negative x over that common denominator of x plus 1 times x plus 1 times x minus 1. I'm looking at that numerator, and again, there's a GCF, so we're going to factor out that x that's in common, leaving us with 3x minus 1, and then still over x plus 1 times x plus 1 times x minus 1. I'm looking, does anything cancel out there? No, nothing cancels, but it's good to check, so that's going to be our final answer there. If you want to pause here and try 10, it is much like number 9. It'd be a great time to pause and see if you can do it, and then we can compare answers. So I will go ahead and get started there. I kind of took a little bit of my room, but that's okay. So I need to factor each of these denominators first. So I'm looking for the factors of 12 that add to 7. That's going to be 4 and 3. So x plus 4 and x plus 3. And then that difference of squares factors pretty easily to x plus 3 times x minus 3. And then I can find my common denominator. So they have an x plus 3 in common. I will need the x plus 4 that's not in common and the x minus 3 that's also not in common as well. So my common denominator is going to be x plus 4, x plus 3, and x minus 3. And the order of that doesn't matter. If you have it in a different order, it's fine. Make two fractions, each with that as the common denominator. So from this denominator to that denominator, what is new? The x minus 3. So we multiply the numerator also by x minus 3, and that would give you 2x squared minus 6x. From this denominator to that new denominator, the new thing is the x plus 4. So the numerator needs to be multiplied by x plus 4, giving you 3x squared plus 12x. If we combine those fractions, we're adding again, so there's no negative to distribute. 2x squared plus 3x squared is 5x squared. The negative 6x plus the 12x is going to be a positive 6x. And then I would have the x plus 4 times the x plus 3 times the x minus 3. Looking at the numerator, and there's a GCF again of an x in common. If you divide by the x, you'd be left with 5x plus 6. Over that common denominator of x plus 4, x plus 3, x minus 3. And again, nothing cancels that time. Sometimes it will, and that's the case. So again, if you have any questions, please reach out to me. I'll be available on Google Hangouts or whatever you need. I'll talk to you soon. Have a great day.